All right, this is your pre-lab video for your Half-Life lab. Okay. And this Half-Life lab, which is a dry lab, okay, we're not going to be really using any radioactive materials, but you are going to model half-life by using pennies. Now pennies, which have heads and tails, right, which all coins do, but that's beside the point. Pennies are cheaper. The pennies are going to have two isotopes. Okay, we're going to have either headsium, which is HM, or we will have tailsium. Now you are initially going to start off with 100 pennies, and you need to position them where all 100 of them are face up. Okay, so you're going to have, if I was to make a table, okay, like I am right here, right, you're going to have some trials, right? So we have time. That's a nice T. Time equals 0. Time equals 1. Time equals 2. Time equals 3. Time equals 4. We're going to have 4 trials, and honestly, every single one of these times is equal to 1 half-life, right? So at no half-life, your sample of pure headsium would be 100% headsium and 0% tailsium. Okay? Then you're going to put them in a container, dump them all out, and then that would be your first half-life. Every single time you dump one, that's going to be a half-life, right? So I'm going to take my data, and let's go ahead and say it was 75 and then 25. Obviously, the headsium and the tailsium, I'm not going to destroy that data, okay, or I'm not going to destroy that matter, so to speak, with the tailsium. It's just, it becomes tailsium. So now with my next trial, I'm going to have this 75. I'm going to flip just the 75, right? Because these tailsium have already decayed. They're already my daughter product, all right? They're not going to go away, but their numbers should increase now because those tailsium are more stable than the headsium. They are not going to go backwards back into headsium. So with the next trial, let's say of the 75, I have 40 of them stay as heads. Well, if 40 of them stay as heads, that means the other 35 are now tails, which means 35 plus 25 is 60, right? And of course you can see that the headsium plus tailsium must always equal 100, right? And then in the next trial, I'm going to take this 40, and those are the only ones I'm going to flip, right? And let's go ahead and say if I was to flip them for a third time, I end up with 22, right? So my 22 headsium, which means I would have 78 tailsium. And then in my fourth trial, I'm going to do the same thing once more, but with just the 22, and let's say I only end up with 10 heads left over. That means my total number of tailsium must be 90, right? So you're going to do 4 trials, but what I would like you to do is, in addition to having your data, I would like you to get the data of at least one other group, okay? And you're going to calculate an average. So for example, if I was to look at somebody else's data and I notice that their numbers, we're going to go ahead and put theirs in red, right? 100, 0, obviously, because it still everybody started off at the same point, right? But let's just go ahead and say they were 80, 20, and then they were 50, 50, and then they were, say, 30, 70, and then 15, 85. Okay? What I would want you to do for your graphing, because you are going to graph this, is you're going to get, in this case, 8 averages. This average, which would be 200 divided by 2, which would be 100. This average, okay? All these averages, and each one of these averages is going to represent a plot on your graph, okay? So you're going to have actually 2 lines on your graph. You're going to have a tailsium graph, or a tailsium set of data, which will have 1, 2, 3, 4, 5 points. And you're going to have a headzium, which will have 1, 2, 3, 4, 5 points. Okay, so you'll have a grand total of 10 points altogether, but you'll have 2 lines, and you'll plot each one. So I would plot my, okay, let's go ahead and I'm going to just throw some line numbers out there, and let's say, oh, my numbers are going down. There's my headzium, and then I would choose, a dash line, since it's going to be all in the same color, most likely. And then my tailsium is a dash line. Okay. Now you guys, mostly, I have you guys do correct, best fit lines. But in this case, I actually would like you to connect the dots. Okay. So your lines may not look like this. They may look very different than this. So I'm just showing you that you're going to have 2 lines on that graph. The x-axis will be number of half-lives. Okay, so write that down since I'm running out of room, so I'll just have you guys write that down. The x-axis is going to be number of half-lives, and the y-axis is going to be percentage. Okay, so obviously when I start off, my headzium percentage is going to be near the top, and then my tailsium is going to be at the bottom. Okay, so that's pretty much it for the lab. Okay, so when you guys come in, you guys can work in pairs. Okay, so work in pairs. You'll have the whole period to at least collect the data. Okay, we can always work on the lab report tomorrow, but at the very least, I need you to gather your 10 pieces of data. I need you to collect another person's or another pair's 10 pieces of data, and then calculate your non-weighted averages to determine what your points are going to be. If you've gotten that done in one day, then you're sitting pretty. If you didn't, then you'll have to come in at lunch and finish. Okay?